Converting a scheme project to JavaScript. Goals: to demonstrate several programming techniques, to build a relational programming library for JavaScript, essentially Prolog, to update an older project. I demonstrate several programming techniques. Parts-based programming, also called 0D, text-to-text transpilation, staged computation, peepholing, blending more than one programming language into the development workflow. Hint at using existing programming languages as assembly language for new programming languages. This is the source code for the Transpilation project, which shows the PBP technique. It's a drawware pipeline with 6 stages. This diagram gets compiled to running Python code in this demo. It also demonstrates stage computation. I divide and conquer the transpilation problem by breaking it up into smaller pieces. Read the scheme file. Replace backquotes with legal scheme code. Replace quote shorthand with legal scheme code. Mark constants to make it easier for the final stages to deal with the code. Generate a first cut of the JavaScript code. The code is correct, but contains lots of redundancy. Use a peepholing stage to improve the code. The original code contains macro and backquote syntax. This can be rewritten in a more verbose but legal manner. Similarly, shortcuts can be replaced by more verbose code. To make it easier to generate JavaScript, I rewrite constant lists and constant symbols using Unicode symbols. This is no longer legal scheme syntax, but it is easily parsable by stage 5. This is an example of the first pass of generated JavaScript code. The line of scheme at the top is transpiled into the ugly but legal JavaScript at the bottom. Calls to functions, push, set, merge, and pop have been added to maintain scheme's expression semantics in the generated JavaScript code. The final stage uses text-to-text transpilation to pattern match one redundant pattern in the code and to replace it by less redundant code. For purposes of this demo, I manually reformatted the final JavaScript code. It looks like reasonable JavaScript code. It could be optimized further, but there is no good reason to waste time optimizing it. This runs fast enough on a development machine. If we wanted to push this code into production, we might spend more time improving it. Now, the demo of the code running from the command line. First, we run the original scheme code. Then, we generate JavaScript code and run it. The result is the same. It takes very little time to generate the JavaScript code, even though there are some 5 shellouts from Python to JavaScript in the pipeline. The source code diagram is converted into a Python program. The Python program transpiles scheme code to JavaScript code. The Python program uses the Ohm JS parser, which is written in JavaScript. I'm mixing the use of several programming languages at development time, but it all runs fast enough and doesn't need to be recoded in only one language. Here's what the modified code looks like after the first 4 stages. And here's the final peepholed code. It doesn't need indentation. Node.js can run this code as is. The generator is fast enough for use during development. The generated code is Python, but 5 of the 6 stages shell out to JavaScript to run T2T. Although this looks inefficient, it runs fast enough on a development machine. Efficiency means different things for production code versus development tools. Here are some snippets from the grammar and RWR files. There is a one-to-one correspondence between the rules. Ohm JS uses the grammar to parse incoming text into syntax trees. Normally, Ohm JS expects programmers to write semantic functions in JavaScript, but the use of the RWR little DSL makes it possible to parse and rewrite text without having to write any JavaScript. Here are references to code repositories for the running code, and Niels Holm's original code and the old project, which I've updated. I write articles about simplifying programming. Here are some places to find those articles.